All right, so I have two circuits here. In my left direction, I have a DC circuit, whereas in my right direction, I have an AC circuit. Now, the first difference is that current flows just in one direction in DC. So if I close this switch, you notice here that the conventional current flows just in one direction. I'm saying conventional because it is flowing from the positive terminal, okay, through the circuit back into the negative. If I switch to this other mode, okay, so can you notice that the electrons are flowing from the negative terminal of the battery through the circuit? So this is real current, whereas conventional current, you have the current flow from the positive terminal. Now, if I close this other switch, you notice that current flows in two directions, the backward and forward directions. Can you notice that? Even if I switch to the conventional mode, you notice the same thing, okay? Forward and backward directions. Is that okay? Okay, another difference lies with the circuit symbol. So if I change to this mode, you notice the circuit symbol for a DC source, whereas this one is for an AC source. The next difference, I think I should change back. Okay, so the third one is the source. So DC is primarily sourced from batteries, whether primary cells or accumulators. Okay, you can as well get it from your solar panels, whereas AC is basically sourced from AC generators. You can also get it from the mains, that is the wall outlets in our homes. Is that okay? Now, the fourth difference is that frequency plays no role with respect to DC. So can you notice that the bulb here is steady, whereas the bulb here goes on and off, like that. So if I click on this source, you notice that there is a provision for us to either reduce the frequency or increase it. So if I increase it, you notice that the bulb begins to go on and off in a much faster way. Can you notice that? Okay, actually the bulbs in our homes are AC bulbs and they go on and off. But because the frequency we use in Nigeria is 50 Hz, that means the bulbs go on and off 50 times in 1 second. Frequency means the number of cycles made in 1 second. Okay, often our eyes are tricked into thinking that the bulbs are steady. Meanwhile, in actual sense, they are not. Is that okay? All right. The next difference lies with the graphical representation. So let me show you. If I pull out this guy, this is a part of an oscilloscope. This one is for voltage, whereas this one is for current. Now, if I connect the negative probe to the negative terminal of the battery and the positive probe to here, it's telling us out of range. Let's see. Okay, so you just notice a straight line. So graphically, DC is represented with just a straight line. Whereas if I change to this other circuit, okay, so you notice this, okay, like a waveform, a sine function. So graphically, it is represented like this in a sinusoidal manner. All right, that's for AC. So same goes for current. If I connect this guy, you notice just a straight line. Whereas if I change to this other, you can place it anywhere. You notice sine function, okay, like a waveform. So in a sinusoidal manner. All right, the next difference lies with the difference between resistance and reactance. For instance, here, can you notice that we connected only a resistor, whereas here we have a resistor, an inductor, and a capacitor. I think I'll discuss this in our next video. All right.